Hey, Mr. Danahauer here. Today we're going to be talking about ions on the periodic table and the trend of ionic radius. So let's remember ions form when elements gain or lose electrons, and let's look at some of the trends we see on the periodic table. If we look here in group 1, all of the ions have a +1 charge, and so let's think about why is that. The metals tend to lose electrons. They have a low ionization energy, a low grasp on their valence electrons, and they're able to get rid of those pretty easily in order to achieve a full octet. So why do we get a +1 charge in the first group here? Because all of those elements have one valence electron and they're going to lose one valence electron. Remember, if you lose an electron, you become more positive for however many electrons you lose. So because every element in the first group here has one valence electron, they all lose that valence electron to become ions and they form a +1 charge. Group 2 is the same way, but the pattern here is 2 valence electrons, so each one of those metals loses 2 valence electrons to become +2 charge. Okay. Now if we jump over to the nonmetal side here, we can see a pattern as well. Remember that nonmetals have a high ionization energy, a very high electronegativity. They want electrons and they're going to gain electrons in order to fill their outer shell. So remember that everybody in the second to last group here, the halogens, those elements have 7 valence electrons. And they want to gain 1 electron in that p sublevel to become p6 and have 8 valence electrons. So their s and p orbitals are full. Because all of these elements have 7 valence electrons, they're all going to gain 1, giving them a -1 charge. The same thing here with the oxygen family, -2 charge for all of those because they want to gain 2 electrons to have a noble gas electron configuration and fill their octet. So they all have a -2 charge. Likewise with the nitrogen family, they gain 3 electrons to have a -3 charge. Okay, so those are the certain trends you should notice. You should be able to predict using the periodic table what charge the main group elements are going to form, including aluminum, but not necessarily the transition metals or the post-transition metals here, because those have variable charges. So let's talk about that's the trends for ions. Let's talk about atomic radius versus ionic radius. So whenever we look at an element, if it becomes an ion, its size is going to change. If we look at metals lose electrons from their valence shell, and so what used to be a valence shell here no longer has electrons in it, so the radius on this sodium atom, when it became a sodium ion with a positive charge, got smaller. All right, so what you need to know is that elements like metals, when they become cations, the cation is always smaller because the element is losing electrons. Cations are smaller than their neutral element. All right, let's look at anions now. So if we come over here to chlorine as an example, remember that chlorine has 7 valence electrons. It wants to gain 1 more, and so if it does that, and we don't really see anything change here. It's become an ion, but the size doesn't look like it's changed. Remember, there's repulsion between all of those electrons. And so whenever you put more electrons in that electron cloud, there's going to be more repulsion and the cloud's going to get a little bit bigger. So anytime an element gains electrons to form an anion, the anions are going to be larger than the neutral element. So that's the trend that we see. And here's one more picture just to help you. This is pulled off the web. The gray here is the ion and the colored is the neutral counterpart. So we can see all of these metals here. The ions are smaller than they would be if they were neutral, which is the blue is neutral. And the anions here, okay, the gray is again the bigger ion because these are negative anions. So you should be able to predict the charges of the main group elements. You should be able to say if a cation or anion gets larger or smaller than the neutral element and know the trends for those on the periodic table. Have a great day.